IoT. That's clearly says that this artificial Internet of Things. Okay, so here we focus on the word of connecting devices to intelligent that makes the decision making system. Okay, so IoT enables machine not only to secure data but also to the learn, predict, and act autonomously. Correct. So the IoT, that is data collection, and AIoT is the data plus intelligence plus decision. Okay. So the next, sir. So how it be, what the challenges are there in IoT that can be removed by AIoT. Okay, so we see here that the first challenge is that called to be the latency, that is the delay when we are sending the data, because in IoT the IoT devices are sensor collecting the data and send their data to their devices. They do not have the intelligence like a camera. They have to capture the image, but they are not deciding what categorization of the capturing images is there. They just send the data to the cloud, and the cloud having the they have to be some intelligence, and that can be decided what type of these images, and then send come back to the that particular devices. So sending the data to the cloud and come back from the cloud to that particular edge devices, that is taking some time. That is called to be the latency. That is processing data locally on devices can be more easily, but in IoT we have just captured the data and sent to the cloud. That can be removed by in your AIoT models, and they have to be some teeny type of machine learning model that can be implemented into the particular devices so that it can be very easily for that. So the artificial intelligence of things combines the artificial AI with the Internet of Things to create intelligent, autonomous, and adaptive systems. It enables device not only collect the data but also analyze, learn, and make decision in a real world. So the first challenges in IoT, that is to be called latency. Second one is bandwidth, because when we are sending the data in the cloud and revert back from the cloud to the particular devices, we have a big need to be bigger bandwidth system. So the lower power of the traffic, we can be use this such type of teeny ml in our low power devices so that it can be easily enhance the bandwidth problems. Okay, and the third major challenge is the energy saving and privacy. Nowadays we see that when we are sending the cloud, when the data sending the data in the cloud, this is more things is there. So privacy, like cryptography of things that can be needed. So we need to be the like blockchain technology we have to be needed. So when we are sending the data is the cloud, there's a more chance to be interrupted the data on that particular cloud. So so if we implemented this teeny type of ML in our devices, though it can be increase this energy saving as well as the privacy of the system. So for this, IoT devices have the three major challenges. That the major challenges is latency, that is called to be the delay, and reduced bandwidth and bandwidth point of view, and the energy savings. So all these three challenges that can be reduced by when we are entering the that AI OT platform. Correct. So next, sir. So this is nothing is a ML model that we say that this is a teeny ML model, and this teeny ML model can be implemented in the micro controllers, where you say that this is a our edge devices, where small models can be easily implemented. They have developed, they have learned, they have been trained in other places and implemented that particular in like Raspberry Pi or Arduino, in that particular platform, so that it can be easily capture the data. Just like a camera, there can be image that can be captured, and they can be analyzed what type of images is there, what the purpose of this image is, what type of image is there, so can take the decision. So we need to be the make the intelligence in the edge devices. Okay, not to be sending the data in the cloud, because we have the three major challenges which are discussed. So we have small models that can be implemented in the low power devices, so that the resource constrained devices can be also be utilized. So the IoT architecture primarily focus on the connecting physical devices to the internet to collect and transmit the data for monitoring and control purpose. In context, AIoT architectures enhance this framework by integrating artificial intelligence at both the edge and cloud levels. Not only the edge level, they have to be implemented in the cloud level. If you needed or important data should be sent to the cloud. Okay, but some small part of that particular model that can be easily implemented in the microcontroller, so that the devices can be made some intelligent. Okay, so not the they have not sending only the capturing the data and send to the cloud. They have to now decide what type of action should be taken. Okay, like in traffic control system or any system which are needed to be immediate actions. So some model of that is called TNML model that can be implemented in the particular devices, so that it can be easily take the decision. Okay, so this is called to be the TNML is a branch of machine learning. Okay, is an embedded systems research that can be looks into the type of models that can be run on small low power devices like a microcontroller or edge devices that we discuss, like that is Raspberry Pi, or we say that this is a to be a node MCU like that. Okay, next one. So now come to the our topic, that is our AIoT architecture and framework. So the AIoT architectures, uh, we already say that this is an enhanced version of that particular IoT architecture. Okay, so this framework by integrating artificial intelligence at the edge level as the with the cloud level, enabling system to analyze data, learn from patterns, and make autonomous decision without constant human intervention. Okay, while IoT system, that is previously a traditional system, rely heavily on cloud-based processing and often involves higher latency. AIoT system performs real-time data processing at the edge level and reducing delays and improve efficiency. As a result, AIoT transform traditional IoT systems from simple data collecting into the intelligence, adaptive, and self-optimizing systems capable of predictive analytics and autonomous actions. Okay, so the problem that can be solved by the lack of intelligence, higher latency, manual operation that can be done, and the insufficient uses. That is the problems solved by AIoT. And if you talk about why we AIoT, those so higher demand skills, industrial adoptions like Siemens and Bosch, top level of company, they have to be transferred this all manufacturing unit to the IoT related things. So we need to be the enhance this IoT power by using some artificial intelligence. And in the research area, we have to be develop its AI and autonomous systems. Okay, so so the future of intelligent, automated, and connected system is called AIoT. Okay, so next, sir. Now, okay, this is the our basic layer architecture. So we have focused on this architecture. So this is our main topic, today's topic, that is we have to be discussed. The device are the first layer is called to be the device or perceptions layer, where include the sensors, actuators, cameras, wearable devices, and these are responsible for the data collection for environment. So the first layer of this architecture is to be called to be the device, are where the main sensors are there that can be collect the data. Okay, so this device is called to the perception layer or device layer, where we have to be some sensor, cameras, and there they actually they have to be only the collect the data. Okay, so the next layer that is called be edge AI layers. So previously it's called edge layer, now it's called edge AI. Okay, so where we can be take the data from the that particular perceptions layer, and we have to be tiny ML type of model. They have already trained, and now they have collected data, and this collected data have to be the intelligent now. So the edge layer, that is the edge AI layer, that is data is processed locally near the sources. Okay, now the data is processed and they have to be reduce the latency and bandwidth uses. Okay, runs also runs the lightweight AI models, normally that is detections and image recognitions. Okay, like example, smart camera detecting instructions. Okay, now we correlate this smart cameras is there, they can be detect the image and then they can be take the decision accordingly. Okay, so these things should be happen in the its AI its layer, and this is called to be the AIoT edge, as well as the basic layer that is called device layer. So these are the two layers that can be very near to each other, and they can be take the decision as per their data collected. Okay, so there need no need to be send the data in the cloud. If the important data is there, we can be send it. So the third layer is called network layer or communication layer, that can be transferred the data between devices, edge and cloud if you need it. And they have to be uses some technology like Wi-Fi, 5G, and that LoRaWAN, Bluetooth technology that can be uses. Okay, that can be ensure, and they can be ensure the security and reliable communication. And the final, that is called to be the cloud and data processing layer, where it can be handle the large scale data storage and processing. They have be perform heavy AIML computations, not to be the small computation. If small computations would be happened, or they can be solved in edge layer, that is called AI edge. Okay, and the last one is that is called to be the edge application layer, where the end user can be use the applications and services like smart cities, healthcare monitoring, and industrial automation, provides insights, alerts, and decision making process. So the how the data should be flow from in our AIoT architecture. So the firstly, sensor collect the real data, edge device process and analyze the data and takes the decision. If the needed, they can be send the data to the cloud by using network transfer data securely. Okay, and the cloud performs the deep analytics and model training, and application delivers the insight in the in that the actions. So this is the our complete architecture of this AIoT architecture. We see that this is the green part of this is called to be the AI and ML layer that can be introduced in the part of edge devices. Okay, so this is the complete AIoT architecture, has a layered framework that enables intelligent data processing and decision making. At the bottom, the device layer. We already say that this is the device layer consists of sensor, smart devices that collect real world data. Okay, such as temperature, health parameters, or environmental conditions. This data is then processed to the edge layer. Edge layer now is called AI edge layer, where the local processing and lightweight AI models analyze the data in real time and reduce latency and enabling immediate responses. The process data is transmitted through the network layer, which uses communication technology like Wi-Fi, 5G, and IoT protocols. Okay, to ensure the secure and efficient data transfer. And the next one is called to be the cloud layer, performs the large scale storage, advanced analytics and machine learning, and the big heavy models. Okay, that can be trained and extract deeper insight from the patterns. Finally, the application layer, that is provides the user interface such as dashboards, mobile apps, and alert systems, allowing users to monitor, control, and make informative decisions. Overall, this architecture demonstrates how AIoT transforms raw data into the actionable intelligence through a seamless flow across all layers, enabling smarter, faster, and more autonomous systems. Okay, so here this is also called the IoT architecture, but we have added one more layer that is called AI and ML layer that can enhance the system, and nowadays is called to be the AIoT architectures. Okay, so the next one, sir. Same thing as there. Okay, so here we see that by one examples, there is some sensors, they have one gateway. Okay, so they have a small type of teeny ML that can be implemented at the device level. Okay, they can collect the data and send to the particular its AI model. Okay, they can be analyzed and take the decision and send to the particular sensor or actuators that can be takes the action accordingly. Okay, and if they are needed to be sent, if they are needed is a heavy data or is a important data, they can be sent to the cloud. One, the cloud have the different types of models in having the in the cloud. They can be also take the decision, save the data in the cloud. Okay, and then if they need it, then is send data to the actuators, so that take the decisions. So the same thing as there. So the sensor, adds cloud and application. Next, sir. So here is in this picture we say that this is the what is the difference between IoT and AIoT. Okay, so that you can be clear picture uh, what type of this IoT is there and the AIoT. So just like a temperature, just like a temperature sensor, we normally say that they can be take the temperature of this particular room, and they can be send that to the cloud. Okay, so this is called IoT. Just is collection, it's a data collection. But in AIoT, now is data intelligence plus decision. Then is collect the data and take the decision accordingly. If the they capture the sensors, they capture the data from the sensor, that what the temperature of these rooms, like in AC, they can be on or off. They can be how, if the temperature is going to be the high, then the AC should be on, and the temperature is going to be low, then AC should be down. So this decision should be taken in edge level. So that is called AIoT. So that this is the basic difference between AIoT and IoT. Correct. So like data processing, mostly in IoT, the data processing should be done in the cloud level, but in IoT, it can be enable the intelligent decision making. Like data processing, mostly in the cloud, but in here is the edge. Intelligence limited are rule based in IoT, but advanced AI/ML based analytics that can be happen in the AIoT. Response time, higher latency in IoT, but if you talk about the IoT, is a fully automated self-learning system that can be AIoT. Data handling, that can be send raw data to the cloud in IoT, but in AIoT, they have the filters and process data that can be locally they have been handled. Okay, the complexity should be in IoT is a similar architecture, but in AIoT is a more complex due to the AI integrations. Okay, and like some examples by we have see that the use cases like smart home or basic monitoring, but in AIoT, smart cities, predictive maintenance, autonomous system that can be handled. So this is all about the IoT and AIoT uh, architecture differences. Next one, sir. One thing that is active system in IoT, they have to be the passive system. Now AIoT makes to the that is say that is the active system. The passive system makes to the active system. Correct. So this is the some future trends of this particular AIoT architectures. That is the AIoT market is now is growing rapidly and expected to reach the trillions of dollars. Okay, in the coming futures. So the AIoT is the brain that makes the IoT truly intelligent. So the market is to be expected to be the trillions of dollars in next few years. Okay, so if you talk about the future trends, they have to be the real-time processing at the edge, reduced latency, smart city, okay, integrated with the 5G and 6G, that is ultra low power latency network should be there. Okay, distributed intelligence, AI models at the devices, edge and cloud levels are there. So the changing market share is also we have to be 70% market share in the software services by 2030. Is a big thing that the IoT should be changed the market scenario near about sharing of the market share that is 70%. Okay, so the great is the growth is very rapidly, and we need to be the IoT device 39 billion IoT device in 2030 they are connected to each other. Okay, so we see that the market is growing rapidly from now to the near about to the next 5 2 years. Next, So we here we see that this is a traditional IoT and IoT driven companies are there. They can be use this real time decision making, predictive maintenance like AI, industrial IoT. They have to need to be the predictive maintenance by using some machine wise and all these things. They can be collected by the sensor and then can be decided. So the company is also so adopting such type of IoT architectures, IoT robo arms are there. So they can be changed all the scenario of this industry. Okay, near about to be exponential growth. We can see that that is called a IoT connectivity, data analytics, adding AI in IoT, adds AI in intelligence, and now is we have the fully AIoT integrations in the industry. So it can be changed. So this is the companies. Next one, sir. Next one. This is the market trends. Yeah. So next one. Challenges and security in IoT. What the challenges should be there. That can one is major challenge is the security and privacy. High implementation costs because these are implemented in the edge level. Okay. Data management complexity is also there. They can be handled massive amount of devices. So not I'm talking about one devices. They have the thousands of devices. They can be collect the data and take the decision accordingly. So this is the major challenge and they are the limitations. Okay, so we are not implement the heavy level of models in the edge level, or we say that device level. Otherwise this can be take it can be increase the burdens. Okay, interoperability uses the difficulty of integrating different IoT devices. So critical consideration for IoT data encryption, secure communication, data management complexity, interoperability uses. So critical consideration for IoT implementation. Okay, so we have to be more secure, more secure algorithms are needed. Secure cryptography type of things will be needed. Encryption data should be needed. Secure communication is needed. So the AI based threat detection is also needed for that particular devices, because the all devices are connected to the internet, so it easily can be captured. So the this security point of views, this also there in the AIoT architecture. Next one. So now we are talking about the cases, some case study. We have here the three case study, especially smart agriculture, smart healthcare, smart street lighting. We're focusing on this how they have to be dramatically changed in these areas. So particular these areas can be enhanced by using some this. Architecture that is called to be the IoT architecture. So the firstly we have talked about the street light, smart street lighting. So the AIoT based smart street lighting system that is demonstrate how integrated IoT with intelligence enables real time automated decision making and efficient resource utilization by combining sensing, edge processing, cloud analytics, and user applications. The system significantly reduce energy consumptions that has to be energy consumed by the this particular smart street light devices. Okay, so this case study highlights the practical implementation and benefits of IoT architecture in a smart city like environment. Okay, so I'm just focusing on the two case study, that is the smart healthcare as well as the smart street light. Okay, so the firstly we talk about the smart street light. Sir, next one, sir. So this is the smart street light. What the problem statement is to be high energy congestions due to the continuously on the street lights, as well as the lack of real time monitoring of environmental conditions. And these are the problems statement of this particular case study. That is the delayed response to fault and abnormal situations. No integration of multiple urban monitoring functions are there. So how they solve, they have to be solved by some our AIoT models. That is the how the data should be flowed. The sensor we are data, if there is there it capture the important data, it can be sent to the cloud. Otherwise they can be take the decision in the edge level. Okay. And according to the sending the data in the cloud, the authority monitors this particular by using their dashboards. Okay. So we see that the some benefits like 40 to 60% we have saved the energy, and we have to improve the public safety and reduce maintenance costs, also the better urban plannings for data insights. So this basically this is a case study that presents the AIoT based smart street lighting system that designing to improve the energy efficiency, public safety, and environment monitoring in the urban areas. Okay. So traditionally, street lights, this system is integrated sensor, heads, AI, and cloud analytics to automatically adjust lighting, and it detects events such as the traffic movement, noise pollution, as well as the air quality changes. Okay. So this is the problem statement: high energy consumption due to the conditionally on street lights, lack of real-time monitoring of environmental condition, delayed response of fault and abnormal situations, no integration of multiple urban monitoring functions. Okay. So the working of this particular model. Okay. So we see that in the next slide. So see, this is the actual scenario where there is a gateway, there is sensor, and they are collecting, data collecting, and they send to the control and management center. And we have the some like we see that this particular area in the road, they have the traffic light, and they are implemented this particular system to the particular traffic light system. Okay. So if the light is not continuously on, if there is no movement, so all the motion sensor is implemented with the system. So they can be not to be on at that particular system. Okay. If there is any movement, they can be on the system and send and then collect the data and take the decision in the light D band, or particular in the lighting mode only. Okay. So the firstly sensor collect the environmental data, the traffic data, and then act accordingly. Edge devices process particular data locally using AI. That is AI or IoT. Okay. Lights adjust automatically, either dim at the brighten level. Okay. Important data is sent to the cloud. If the data is important, then sent to the cloud. Authority monitor via dashboard and receive alerts. Okay. So see in the next slide, sir. So this is a particular how you your data should be work is if you are using the smartphone, you can be see the this particular data are in your dashboards. Okay. So we are using here one protocol that is called MQTT protocol has been used. There is a very lightweight protocol that is developed by the one company that is called to be the Microsoft. They have to develop for a particular things where the Facebook are using also the MQTT protocols. Okay. Message queue telemetry protocols. This is a heavy topic, but we have seen here the MQTT protocol is used, very lightweight protocol that can be send the data from device to the particular cloud or particular node. Okay. So this is a S-based AI algorithm that can be used in the particular devices. Next one. So see, this is the dashboard of that particular this case study. Here we see that this the important data is sent to the cloud. When the light are not to be the demand written, then it can be sent to the cloud, and the authority monitors by this dashboard and receive alerts. Okay. So the benefits is to be this system is to be reduced 40 to 60% of the energy consumptions. Okay. Improve the public safety also. So the pollution control is there by using these devices. Reduce maintenance cost. Also, the predictive alerts are there. Better urban planning and using the data insights. So this is the particular one case study, and the second case study is to be the related to the our the patients and doctors systems. So next one, sir, next. Okay. So in this case study, we see that the smart healthcare system, what is the problem statement of this case study, that is called to be the for the remote patient monitoring, that it enables the continuous tracking of the patient's health using wearable devices. Okay. real-time AI analysis are there, and cloud-based medical system that can be reduced hospital visits and also enabling early disease detections. Okay, so the problem is that the limited continuously monitoring of the patients outside hospitals. Okay, delayed detections of critical health conditions, and overcrowded of hospitals and high healthcare cost, and there's a lack of real-time data for the doctors. So this is AIoT architecture that can be implemented in a healthcare sector, where the patient can be remotely monitored by using the wearable devices. What the working process is there, the we say that this is a wearable sensor are continuously monitor the patient's vitals. Okay, and edge device that can be implemented with this wearable device that can be analyze the data in real time, and if there is abnormal patterns are find out, then like heart irregularity or anything else that can be detected instantly, then alerts are sent to the doctors, and they also send the data to the particular hospitals also that are related to that particular persons. Okay, so the cloud storage and analyze long term health data, so that it can be decide what type of diseases in the future they can be faced. Okay, so the doctor access that particular dashboard and decision, they can be take the decisions accordingly. So the what impact that can be changes in the particular as a results, they can be early detection of heart attacks like critical conditions. Okay, reduce hospital admissions by near about 25 to 40%, because there is no critical patients are there, so it can be handled previously before that can be happened. Okay, faster emergency response. Okay, if there is any like heart attack or any such type of diseases, that can be send the their particular doctor to their home, and immediately action should be taken. Okay, continuously monitoring of the particular things and reduce healthcare cost also. So in like US and other countries, they send the they give the like those are giving some like hospitals. If you are attached with the hospital, they send one band, like they provide some band, you can be wear this particular band, and that can be easily they can be monitored by your health in the hospitals as well as doctors. Okay, so this is a basic case study where we can be implemented the edge. Next one. This is the particular things are there, hospitals, doctors, and your wearable device, your body should be monitored. Okay, they can be monitored by that can be monitored by your all health. That can be early, they can be detect the heart attacks and critical conditions. Okay, so the admission of near about the 25 to 25% are 25 to 40% are reduced by using these systems. Okay, so that because they are continuously monitored, and if there is nothing, if there is happen in your body, and anything can be increased, then can be directly doctor should be handled by using saying there in dashboard. So the AI based smart healthcare system for remote patient monitoring demonstrate. Sir, next slide. See, here is the IoT clouds and patients, and they all these are related to the data storage are there, cloud data is there, IoT is there, and wearable blood pressure sensor and R related monitoring systems are there. So patients are already having the wearable devices that can be they can be easily monitor the data, your health, and then they capture the data. Okay, and send to the particular doctors if there is to be happen. Okay, so the monitor demonstrate how integrated IoT devices with AI enable continuously real time health monitoring and early detection of critical condition by combining the wearable sensors, edge intelligence, and cloud analytics and user applications. The system significantly improves the patient care and reduce the hospital burden, enables timely medical preventions. So this case study highlights the transformative and life-saving potential of AIoT architecture in modern healthcare systems. Next one, sir. Okay. Now we discuss some projects that is already in the development phase. and identify some challenges, and so you see that how we collect the ideas from there. Okay, next one. So the first is called noise and monitoring condition of devices. So next one, sir. Yeah, already you actually discussed in smart system. Okay, so this is a, smart street light system where we can combine the pollution controlling and noise control and the lighting system. And they are a street lighting system. They are implemented in a one place. This project is going on in my supervision in our university lab. So and we already filed this particular, because we are integrated all these things, and we using some teeny ml decision making system in our particular street light system, so that it can be enhanced this like traditional AIoT systems. Next one, sir. So this is the actual implementation of this particular system by using Raspberry Pi 4. We have different types of sensor are there. This is the connecting diagram. Okay, so the noise, how the noise should be controlled, how we detect the movement in the particular system, how the data should be sent. So the GPS module is also implemented. So this is the particular implementation part of this particular devices. Next one. So next project is called Watriot. Watriot, that is the you everyone have the in house their water purifier system, but continuously monitoring of that particular water is not there. If we need to be when we are the tests and test are changes in the system, then we monitor, and then we capture this particular water, so that it can be shows the what the pH value is there. Okay, so the so here and we see that if we have your water tank have the near about 5 to 7 liter, near about or 8 liter, and if we reduce the 1 cup of water from particular there, then all the machine membrane and all the motors they can be run, and then start the running, and then making the water already we have the enough water in our tank, but all the systems are running every time. So we are reducing some particular water. So we are focusing here with the three major challenges, that continuously monitoring by pH value, as well as this they can be have to the every times they have the motor runs in spite of having no water inlet. This result the this the burning of the motor is in the circuit. Okay, because it's the electronics devices. Okay, so see the next one, sir. Yeah, we see that this is a water tank where we can be implement this, and there is no need of sending the data to the cloud. They can be machines should be they can be analyze the particular things and send alert to the devices, and they take the decision. Okay, so this is a smart purifier system that can be implemented. Major things is to be not to be every time should be machine should be run, as well as constant monitoring of the pH value of the water. Okay, next one. Next one. So the low cost wearable health monitoring device for pregnant women, that is also our project that can be having. We have already submit this patent for this particular project. So this project is basically we made for the urban areas in India's, and we also have the talk with the government so that it can be easily implemented. Okay, so the problem faced by women during pregnancy, that is regarding the health issues, whether they are in the serious or not. But when they are serious, then it can go to the doctors. Okay, so we low cost device we can be made by using IoT, and this edge devices that can be takes the data like pulse rate or any in other related the data should be collected from the particular patients, and then sent to the alert to the doctors, so that can be easily can be handled. So the medical facility are not in that good, rather treat pregnant women. So for that, in the rural area, especially rural areas, the women cannot be go for a routine checkup, which leads to the health problems. Okay, which are like injuries in life and the danger are both in the mother and the baby also. So this will be reduce the rate of maternal details. Is already they have a lot of devices already developed, but we have developed a very low cost devices in urban areas, so the government should be freely provided. Okay, next one, sir. This is the all about architecture of this particular. This is a smart board, IoT connected board for legacy devices, fire detection and already systems, like a smart electricity board. Okay, we see that you see that this. I will send this PPT. You can go through that. They already discussed, already developed on. Next one. This is a particular layout of this particular board using Raspberry Pi, easily implemented. They can be if they are like if you charging your mobile phone in this particular things. So traditional boards, they can be continuously on. Okay, but if you are having to particular such type of AI based IoT devices in your board, so it can be easily if you are on your charger is on, they can be off automatically if your mobile or your devices are not connected. Okay, next one. Okay, is a smart tea maker. Next one, sir. This is a smart tea maker. We already granted the patent on this smart tea maker. Okay, next one. Fruit and the critical part of the business, which is that includes a very important part, which is deliver in the fresh product of the destinations. Okay, so the is related to the when we are sending the fruits to the one place to another place, it can be useful for that particular that can be not big damage on the fruit or any things are there. So this can be developed. Next one, sir. Yeah, smart locker. Okay, they have to be already developed in our lab. Next one, sir. You go on, go through that particular slides. This is a smart locker. Intelligent IoT-based pet feeding machines are also there. Next one. This is a pet feeding machine. Yeah. Next. These are some smart layout for integrated all this system in a one place, that is called a smart city projects. Okay. A medicine box is also developed IoT based. I'm just showing to you some projects that can be you can be like motivate for in the topic of the IoT. Okay. Next, this is a smart home. Thank you from my side. Hope you learn something learns from this lectures. So any questions?
Yeah, thank you
It's
very much,
open to you.
Dr. Kumar, for your very interesting presentation.
Thank you,
I would
sir.
like
Thank
just
you.
to propose a session answer question from my students. So you just see a very complete conceptual of AI plus IoT. It is a very interesting term becoming AOT. So they blend each other because that's true that we are now needed both of that system together. So students, if you have any questions,
One
could
thing that I want to mention here,
yeah, please.
students, this area is totally practical. Actually, this is the total practical. If you
Mm.
in my hand, I have the Raspberry Pi, I have the sensor. Then we collect the data and then send to particular using thing speak, thing works. Okay, then you realize, and then you think that, and then you motivate from this, and then you can be, all the companies right now, all the companies, they are implemented this such type of the traditional, they can be remove this manufacturing units, and they adopt the IoT architectures. Okay, so this lecture is actually theoretical lectures, but we are not we say that this is if there is a practical, we have a Raspberry Pi, and then how to collect the data, then you more interesting are there. Okay, so if I if you need it, I will come in your country, and then I will give some lectures on that particular 3 days or 4 days workshop, so that you can be realize that how the data should be collected, and how the data should be sent it to the particular things, and how the data are analyzed in particular devices. Okay,
Yeah, I
so
think you
continue.
already show so many interesting example as a project for our student. I am sure that your example will motivate our student to do some
Yeah.
same kind of project in IoT, because sometimes they just need some idea on how to develop and propose some idea on this kind of conceptual of IoT. Yes, student, please raise your hand if you have some questions or remarks regarding this course from Dr. Kumar. Please, you have a session. Yes, the first question from Rafli.
Check, check. Hello, sir.
Yeah.
Let me introduce myself first. So, my name is Rafli Ahmad, and I'm from Ilkom Class A. I would like to ask about the what is it called, the lightning function. So, earlier in the slide that explained that traditional thread lightning system are consume high energy because they're always on. So, my question is, how effective is the AOT system in reducing energy consumption in real world implementation? That's all that I can ask. Thank
Yeah.
you.
Thank you
For
very much,
implementation,
Rafli.
for implementation point of view, there is a lot of tools are available. Okay, you can be used a particular tools, and like in our lab we are using the ThingWorks. Okay, so ThingWorks is also a big platform that industry is also using, like Hero Honda company, they have using this particular ThingWorks, and they enhance their that particular manufacturing unit by near about to 40 to 50%. They
Mhm.
have to be developed, they can remove the human interaction, and using the sub robo arm and all these things. So in market there is a lot of tools are available for implementation. Okay, you learn from their particular tools, and you can be implement.
I, I thank you, sir. Thank you so much for answering my question.
Do you have any other remarks, Rafli? Any
No,
discussion
not at
on that?
all. No, no.
Okay, that's enough. Yeah. Thank you, Rafli. Other question, please? Or maybe you have, um, I don't know, some preliminary idea so you can discuss it now with Dr. Kumar so he can give you some motivation and how you do your project in IoT, please. No? Okay, while waiting, I have
If you
some.
have any question, if you have a question, send me the mail. My mail ID is ajitesh.kumar@gla.ac.in.
Sure. I will share your profile. So Dr. Kumar, we have here one question written on the message. Hi, Dr. Kumar. I'm particularly interested in the security and privacy implication of AIoT. Given that AIoT shifts the decision-making power from the user to the machine, how do we ensure that we are not transitioning from tools that assist humans to humans following the directive of a machine? Where do we draw the line between helpful automation and algorithmic control over our private behavior? I think it's a very general and hype issue on this kind
So
of
now we have
yeah,
a
please.
new for security purpose. You can be use the blockchain technology. You can in Google you can be search my research articles that is related to the blockchain in IoT. Okay, so we develop a one algorithms related to the blockchain. They can be enhance the power of that security. Okay, they can be send the secure data from one network to another network. Security is the main concern, and in coming coming days, because the internet is everywhere, So we need to be the more secure algorithms and more secure system of the particular implementation. So it's a very good area where you can be work in the security, IoT, and ML. You can be combined all these things, and you get the good things to be particular for your project and particular area for your research areas.
Yeah, it's a good concern from the student. I mean, technology will always comes with a double side knife. Yeah. So we need just to analyze it clearly between the impact and the risks between the technology. But I think, I mean, in so many direction now, technology tries to limit that possible risk. My concern is about how the hardware technology can follow the need of the software development technology in terms of making everything in a tiny module. What do you think, Dr. Kumar?
In tiny module.
Yeah, the tiny ML as you
Actually, the
confirmed.
tiny ML is nothing. It's a part of the ML. Okay, so
Okay.
the is implementation in the only the devices. Not they are developed in particular. They already trained
Hmm.
in particular cloud or anything else. They can be implemented only the particular devices. Otherwise, the burden could be increases.
Okay.
So the train module and train model in the implemented in particular devices, so that can be easily can we take the decision, or we say that we said that the intelligence. Okay. So, but if any heavy traffic, heavy load, or any important things should be there, they can be transferred to the main ML that is implemented in cloud, and in the cloud they have to be trained, but the trained model should be implemented in the particular devices. That is what is called TNU ML.
Okay. Yeah. Thank you, Dr. Kumar. Any other question from student or lecturers that joining our session this morning? No. Okay. So you have no question for today's session. You can just send an email to Dr. Kumar. I will share the information after, or you can just googling the profile, Dr. Ajites Kumar from Gla University. He has an expertise in IoT, and I believe that so many final project thesis from our student will come from the IoT domain because it's very popular topic, research topic for the period this year from our student, and you can just learn with some example of paper published by Dr. Ajites Kumar. So to end this session, I would like just share a token of appreciation from our university, from our faculty for Dr. Kumar. This is the certificate of appreciation from our Dean of the Faculty of Engineering and Vocational Universitas Pendidikan Ganesha in
Thank you so
recognition
much, sir. Thank
of
you so much.
your contribution as keynote speaker for this session. We would like thank you for your time and your
Thank
valuable
thank you so much.
talk. We hope that we can collaborate in the future
Yeah,
in a more
surely, sir. Sure,
implemented
sure.
IoT
I'm
project with
happy
our
there.
student.
Sure, sir. Sure.
Yeah. So have a good day, Dr. Ajitas Kumar, and see you in other occasion. Thank you very much, student,
Okay.
for
Thank
Doc,
you, sir.
joining this session.
Dr. Vidu, it's am I audible, Dr. Vidu?
Yeah, yeah.
I
Sorry.
am Dr. Rahul Pradhan from GLA.
Yeah, Dr. Rahul. Yeah, how are you?
Dr. Vedu, we have given this session. So, if any chance in the summer or in the winter you have any, if you can plan a workshop offline for your student over
Hmm?
there, so please do let us know. We will send our faculty members for there to take this session.
Okay. Thank you for this offer.
Yes. Sir.
Yeah, thank you very
And
much, Dr. Rahul.
yes.
Yeah, based on our communication, here we still discuss about the possibility of sending student and lecturers also to Bla University India, but yeah, we're still analyzing the budget and everything related to that. We will inform you, and we believe that you will have very helpful in implementing our collaboration project in the future, Dr. Rahul. Thank you very much for that.
Okay, sir.
Yeah. Okay, see you soon, everyone. Have a good
Thank
day
you.
for everyone. Bye.